All right, good morning, everyone. Um, all right, good morning again, everyone. My name is Kelly Gotze with the National Weather Service in Tallahassee. Welcome to our virtual office tour that we're providing today. I'm joined by Molly Merrifield, one of the forecasters at our office. I'll go ahead and let Molly introduce herself to the group.
Hey everybody, my name is Molly. I've done a couple of these already, so you might be familiar with me, but I'm still fairly new. Got here in July, worked in the Miami office and the Houston office before that. I'm excited to be here and thank you for joining us today.
All right, great. Thank you, Molly. So as we go through our tour today, we're going to take multiple stops through our office. We're going to not only look at some photos, but we also have some video to kind of give you all an inside look at some of the functions of our office as we go through. And we have some of our forecasters that have helped provide this video. But we also want to talk a little bit about what we do at our office if you haven't visited with us before. So if you've never been to our office, we're located on Florida State University's campus. This is a picture of the Love Building, the new portion of it. And our office is up on the 4th floor on the top level there. We also have a balloon launching facility on the roof that we'll get to see today. And we launch our balloons off the roof of the building. So when the current situation is over and we're able to have in-person tours, you all are all welcome to come visit with us. This is where it would start at this building, and then up to the 4th floor, and you get to come inside and look around and see all of what we have set up there. So let's go ahead and get started and move on into our presentation. And please, if you do have any questions, send those in as we go, and then we'll have questions and answers at the end of the presentation. So just very simply, the Weather Service mission statement is all about protecting lives and property and then enhancing the national economy. That last part comes about in part because we're located as part of the Department of Commerce in the federal structure. But when you start to think about forecasts and warnings that we provide, they obviously have an economic value. When you think about tropical systems in the Gulf of Mexico and impacts that those can have on oil platforms and shipping and all of that, clearly there's an economic value to the forecasts that are provided. Where people notice us most of all, though, is with the protection of life and property, which is when we urge folks to take immediate action when warnings are issued. This photo that you see here was just before Hurricane Michael was getting ready to make landfall into our region. It was at shift change between the day shift and the evening shift, and this is some of our office staff and a couple of folks that had deployed to our office to help supplement the response to Hurricane Michael, and ended up getting picked up, and you see there on the Weather Channel, and was shared out. So we have a large team of very well-qualified and energetic folks in our office working for you on a day-to-day basis. So the area that we cover is made up of 48 counties in Southeast Alabama, Southwest Georgia, and the Florida Big Bend and Panhandle, like you see here. It's almost 2 million people that live within those 48 counties. The total land area is about 25,000 square miles, or roughly the size of West Virginia. But also included in that forecast area is about 15,000 square miles of water in the Gulf of Mexico. We forecast and have warning responsibility from the Okaloosa-Walton County line eastward to the Suwannee River, and we go out 60 nautical miles. And so that's a pretty large area that we do have to cover, both land and water. Now, the office itself, even in the midst of what's going on today, operates 24 hours a day, 7 days a week, 365 days a year. And we always have at least 2 meteorologists on duty at all times. And so right now our office has a composition of 5 senior forecasters and 9 general forecasters. And then our support staff includes our management team, so that's our meteorologist in charge, our science and operations officer, our warning coordination meteorologist, our hydrologist, and then we have a technical support team that helps maintain our equipment, but also, if we have an issue with the radar and it breaks, they can go out and repair that, not just equipment within the office. So it's a pretty large group of folks, that we have there in the office. And again, 24/7, 365. So I know many of y'all are probably familiar with what it is that we do with the forecasts and the warnings, but our office has many more functions than just writing a forecast for the next 7 days and then issuing warnings when we have severe weather. We've got a variety of programs. And I mean, I could talk for days about hydrology, but I think I would, get hung up on for that. We'll just focus a little bit on hydrology there with all the river points that we have. But we have aviation forecasts that we write at least 4 times a day for 5 airports in our area of responsibility. We launch weather balloons at least twice a day, and we'll take a look at what that process looks like here in just a few minutes. We talked about our marine area and the forecast that we have to provide for those locations. As we get more into the winter, and things really continue to dry out, we do have a little bit of a fire weather season here in our area, and we provide fire weather forecasts at least twice a day. And then when controlled burns or other wildfires are to occur, we can provide what we call spot forecasts for those. And those are something that are issued as needed. Usually we turn those around in about 20 to 30 minutes. Now, several of our forecasters in the office, they're what we call deployable ready, which means that they've gone through a level of training to where they can provide either virtually or in-person support to emergency management folks during large outdoor events that may be like large concerts and weather is a concern, or you're talking about large tropical events. We've seen with Sally, we saw with Zeta just a couple weeks ago, or just a week ago, really, where we provide virtual support. So we have those capabilities, and we certainly encourage y'all to take advantage of that in future active weather situations. So if we step inside our operations area, and we're going to look at a video here in just a moment of what our workstations look like, you would see computers everywhere. We have, I believe, 7 workstations with some extra spots where we have, portions of workstations to support operations out on the floor. And each of these workstations is comprised of an AWIPS terminal, that stands for Advanced Weather Interactive Processing System, and a Windows computer. And so you can see there on the left side of the screen, that's the AWIPS terminal. We've got a small, and I say small, by today's standards it's small, but a 19-inch monitor there on the far left side, and then 2, I believe those are 25-inch LCD screens there in the middle. That makes up our AWIPS display. And from those 3 screens, we can access just about any type of weather data that you could imagine. We write our forecasts out of there. We issue our warnings out of there. We monitor conditions, satellite imagery. All of that data comes through those portals. And then on the right side of the screen, the other 2 monitors are attached to a PC. And so obviously, we need access to that for email communication, developing our briefing documents, monitoring chat, and a few other programs that we'll use. And so this is just one of 7 workstations that we have out in the operations area. And we'll take a more in-depth look at how our operations area is designed in just a few moments. So we're going to go on a short tour. It's going to be about 10 minutes here a video on the AWIPS workstation. And so this is going to be narrated by one of our forecasters, Eric Bunker, and he's going to show us how the workstation operates, what we can use, how we can get our data. But be sure to look for, as we go through this virtual tour, how our warnings are issued based on radar data. I know a lot of folks may have questions about how we do that and how that process works. He's going to show how we analyze our computer models and how we compose our forecasts and a few other things. So we're going to go into that virtual video. And again, you may need to turn your audio up just a little bit to hear everything clearly. So look for that. And we'll go ahead and get started. This is about a 10-minute video, and then we'll get back into our presentation.
Hello, this is a quick demonstration of the software known as AWIPS that we use here at the National Weather Service. As you can see on the screen, this is a 4-panel of our Tallahassee TLH radar that's got a bunch of different variables that I'm currently viewing at the same time. Right now on the top left, you can see that there is, this is reflectivity. Looks like there's a small shower that's in Alachua County, but that's outside of our area that we focus on. You can see that green outline here is the Tallahassee forecast area. We have a bunch of other different variables here. There's top right is ZDR, the bottom right is correlation coefficient, which we occasionally use to determine the different sizes of objects in the atmosphere, where we can sometimes tell if there's hail or a tornado debris signature based off of what we're seeing in the correlation coefficient here in the bottom right. Now, if I hit this button, we can actually get, I have 4 more variables that are also calculated from the radar that we can see here. In the top left, you can see the storm relative motion. In the right, you can see the velocity. This is sometimes where we'll find a tornado vortex signature, or we also use this to determine whether there's strong winds from a thunderstorm. And also, sometimes a lot of people don't realize, but the beams from the radar, this is actually the lowest tilt. I have it on the half-degree tilt, but as you get farther away on the half-degree tilt from the radar, this beam actually gets higher in elevation. So the farther away you are in our area, the higher you're seeing in the atmosphere. So in this case, I'm looking at Ben Hill County. The half-degree tilt on the Tallahassee radar is actually looking at around 12 to 13,000 feet in the atmosphere. So that's why we have a bunch of different radars all over our county warning area, which helps us see those lower layers of the atmosphere, which helps us better detect some of those smaller features that I mentioned before. Now, we can also use things like satellite, and you can see here, this is the long wave infrared satellite. You see this used a lot, maybe on the Weather Channel, they'll sometimes show this kind of imagery. This is from a satellite that's geostationary, so it only stays in one spot over the United States. And you can see that there's some thunderstorms here currently moving across Kentucky and portions of West Virginia here. I also have plotted some surface stations so we can see a bunch of the different surface stations that are across our area. Tallahassee Airport currently is reading 75 degrees with a 64-degree dew point and a wind out of the northeast at around 10 knots or 10 miles, or it's about 10, 12 miles per hour. So pretty calm conditions out there. Now, sometimes what we'll do is when we do have severe weather, we use this software called WarnGen up here on the top center, this little yellow button, and it'll pop up this GUI that you can see here. And this is where we pick the different type of severe weather type that we're looking at on the radar. And you can go through this GUI and pick how long we want the warning to be, what threat we're expecting. So you can see that some of the wind choices here are 60, 70, 80, 90, and 100 miles per hour. Then the hail choices also increase in size. And then you can also select a bunch of different calls to action, such as large hail and deadly lightning, as well as like large destructive hail and those types of things. So that's where we use our interface, and everybody that's in the Weather Service has to go through a pretty strenuous, it's about a 6-month long training session, and then you go out to Norman, Oklahoma and take a 1-week hands-on training session where you learn how to basically warn for several different severe weather events that have been archived in the past that we use. Also, if you look at this little dot that says drag me to storm, what we do is when we find a storm that we want to warn, we drag this little circle dot here to wherever we want to warn on, and we let go, and it forms a little warning box. And a lot of times what we can do is we can stretch these little triangles here to include the areas that we want to warn. And what we also do is when we hit these back arrows, we can actually time the storm and the motion of the storm to determine the speed of the actual thunderstorm, or whatever feature we're tracking for that. Could be a line of thunderstorms, a single thunderstorm, and that actually will get put into the text product that gets issued from our warning. I'm going to close this. Make sure that we don't issue anything here. And show you guys where we are actually going to be moving to into the future. We have a new software that's just come out in the last year. It's called Hazard Services. Right now, all of our hydro products have actually been moved over to Hazard Services so far. But eventually, all of the warning products that come out of this office will be moved from WarnGen into Hazard Services. So far, it's just hydro products, all of our river flood warnings, flash flood warnings, flood advisories, and the likes have all been moved over to this software. And you can see here, it opened up this window at the bottom of the screen. Right now, we don't have any flood products out. We don't have any flooding ongoing. So right now, there's no products in this bottom white area here. But if we did, they would all show up here, and they would have the expiration time, the start time that they started, and basically we can monitor our products that we've issued through this interface here. And this interface also shows us, you can do a river flood recommender, which will tell us which rivers basically need to go and have a river flood warning issued. And this is coordinated through the SERC, which is basically our local, basically they compute the river flood warnings that occur over in the different values in the rivers based off of the amount of rainfall that we've got. So I'm going to close this and show you guys that we can also use this software to forecast weather. This is where we can look at different model output that gets put into the software and is reloaded every time a model is run. And right now I have plotted the 500 millibar heights and 500 millibar vorticity. And you can see that when I move forward in time, kind of like a movie here, you can see all the different features. And this is how we forecast weather. We look at these different features, and basically if certain types of features impact our area, that's how we know we could be expecting different impacts in terms of severe weather, or just plain old rain, or any type of system. Sometimes you can also utilize this to look at different tropical systems, depending on the region that you're looking at. We can also have different ways to view this. There's different height levels that you can look at that show the different wind speeds at different heights, as well as the different geopotential height of those different pressure levels. And so we use this as well to help forecast even more precise features in the atmosphere. Now, to show you guys where we actually input most of our forecast data, this is called the Graphical Forecast Editor. And you can see here, this is where we input all of the different variables that go onto our weather page online. And you can see, I click right here, this is the POP or percent of, or probability of precipitation in 12-hour blocks here. And we also break that down into 3- and 6-hour blocks in this variable right here. And up at the top is our time going forward. And this green arrow, if you can see that on the screen, shows us our current time where we are right now. So this is where we basically forecast, and we can edit these different grid blocks here to basically show different types of, or basically different percentage types of precipitation in the forecast going forward in time. And we also can use this to forecast different, like how much rain we're expecting through the period as well. And we also use this to forecast temperature, our high, low temperatures, the winds, as well as some marine products down here below. We have wave heights and the different surf heights here that we can use across our forecast zone. Let's see. We also have some hazards. Usually this hazard forecast box is only populated if we actually have hazards that are ongoing. Right now we actually have a small craft advisory out in our offshore waters south of Apalachicola there. But this product is actually expected to expire in the next 6 hours. So this will actually disappear once that happens. But this is typically where we also issue a lot of our hazard products that go out to the public as well. But most of the time, these products are not of the emergency type. Those are usually issued through hazard services or warn them. And that's pretty much all we got here.
All right, so I want to thank Eric Bunker, one of our forecasters, for putting that presentation together. As you can see, there's just a great deal of functionality within that particular software package where we can view a great deal of data. You know, obviously in our area, we have 4 primary radars that we'll monitor: the Tallahassee radar, Fort Rucker, Eglin Air Force Base, and Moody Air Force Base. And then we have radars that are around that. So our forecasters have to be very quick with their decisions as they go through and monitor all of this data. So, but a lot of times when we do have severe weather events in operations, this is a view of our ops floor here, and we'll go on more of a tour here in just a moment. We may bring in more than 2 people. We may have 4 or 5, or maybe even as many as 7 people that can fill up each of these workstations that you see here. There's a couple behind the photograph. There's the hydro cubicle in the back. And that big display board with TVs on it, that's actually just changed in the last week or 2. And Molly is going to show us that here in a moment. But we're flexible on our staffing such that if we need to bring extra folks in to work an event, that's why we have the extra terminals at the ready where folks can actually come in and help out. So, however, during this time where we need to maximize social distancing, we can even perform some functions in a remote capacity when we're having to just do routine weather, but also some functions of tropical or severe weather. So we're getting ready to go on a tour with Molly, where she's going to show us our operations area. And so, you know, as we go through this video, be sure to look for a variety of workstations that we have in there, the different ways that we have to communicate, not just via phone, but there's other ways to communicate, along with our media room, and then our brand new situational awareness display that just got built in the last couple of weeks. Just a reminder, if you have turned your audio up for the last video, you might want to turn it back just a little bit on this one. This one, we had a little bit stronger audio quality. So I'll turn it over to Molly and her tour of the operations area.
Welcome to the National Weather Service in Tallahassee. Take you on a quick tour. So right in here, this entrance here, this is kind of our main hallway. Down there we have our restrooms and kitchen area, along with the Opal's office and the ET shop for the techs who work on our radar and stuff. So excuse us, these are our new chairs that we got. This is our administrative assistance desk here. And then this is our multi-purpose conference room. Excuse the mess, obviously, since we can't gather, nobody's really in there right now. And then walking over this way, past operations, we use this room here for training and just kind of overflow stuff with the big background and light for interviews and things like that. These are our manager offices. This is where Parks, Mark, and then Tom sit, if you have ever visited them. And then coming in here into the operations area, we have, we have 6 workstations here, an extra tech station there for PC or something for social media. And you can sit, that's our ASA Jennifer and Christian. Hi guys. So these are our workstations. Eric showed you some of the AWIP stuff a little bit ago, but these are, we have our radar satellite, our forecast grids, tasks and all that kind of stuff, and then a PC for all our chatting and internet stuff. All the workstations do the same thing, so we can sit down on any station and do whatever we need to do. We have our NWS phone here, satellite phone there, so we can communicate in case of a disaster, EMNet, all that kind of stuff. This is actually our hurricane hotline. It's off right now, but we can use that to talk to the Hurricane Center during tropical events. This is our new SAD display. We have radar up on the center screen right now, but we just got this, so we're pretty excited about it. And then those desks are the IT support, and Kelly's desk, the hydro cubicle back there. And then we can look at the upper air.
All right, thank you, Molly. So that was a tour of our operations floor. And you can see the big situational awareness display. We're really excited about getting that rolled out and getting that set up where we can even take some of the images we look at on a particular workstation and put it up on one of the screens. And so that becomes extremely useful during the severe weather, so that we can, all kind of keep focus on what's going on. But if we're also monitoring other sources through social media or even television to try to find reports, we can use that display board for that. So as Molly ended that tour, she mentioned the weather balloon. And this is something that not every weather office has. There's, I think, I want to say 60 or 70 across the country, here in the lower 48 anyways, that launch these. So the office that I started in Morristown, Tennessee, we didn't have a weather balloon. It was launched at the neighboring office in Nashville. So this is something that we do at our office twice a day, and it is a weather balloon that carries an instrument pack, and it goes from the surface to about 115,000 feet into the air. Goes a long way before the balloon explodes. And then that orange object you see there on the table is a parachute that will bring the instrument package back down. And we may recover somewhere between 20 to 30% of these. It depends on where the wind takes the balloon and whether or not it gets to, say, the Gulf of Mexico. If ours ends up going east, they almost never make it to the Atlantic from our office. but offices that are located on the waterfront, obviously more of theirs are going to make it out into the ocean. The data that we collect includes pressure, temperature, dew point, and wind. And these are very critical measurements because we take them and we send them to DC, and they put them into our computer models. And that data helps us predict the weather even better if we didn't have the data. These weather balloons, we launch them twice a day, same time every day. We launch them at 11 Zulu or 23 Zulu, which now that we're back in standard time, it is a launch at 6 a.m. Eastern or 6 p.m. Eastern. Now, when we get into a severe weather situation or we're dealing with a tropical event, we'll increase the frequency of our releases. And most often in tropical scenarios, we launch 4 times a day for every 6 hours. And so that extra data goes into the model and help produce, improves our forecast. The other thing I'll note is that if you're familiar with the hurricane hunters that fly around hurricanes and then fly into them, they release kind of the reverse of this whole process here. They release what's called a drop song. And it doesn't have a balloon with it, but it does have a little parachute on the back, and it does have a little torpedo-like looking device that measures the exact same data that our weather balloon does, except it's from the level the plane is flying at down to the water surface where it splashes. And so those are direct measurements that we take that greatly help us enhance our forecast capabilities. So our office is unique in that we launch on the roof of the building. I think there's only one other office that launches this way. Most locations, if you look up YouTube videos of weather service weather balloon launches, you'll see them launching in a field or at an airport or something like that. We're launching on the roof of the Love Building. And as Molly is going to show us in a tour of our upper air facility, this can create some challenges. And we'll talk about those after the tour. So we're going to check out the inflation room, how we inflate it, how we track it, and then after the video, I'll mention some of the hazards that I've run into in my time launching weather balloons.
So here we are in the upper air inflation area. We have some of our supplies here, like our twine and parachutes. This here is the actual inflation room where we hook the balloon up to that nozzle there and fill it up with helium. Most sites actually use hydrogen, but here in Tallahassee, we use helium since we're right on FSU's campus. When we prepare the radio song, we set it on that box there. We actually use a spaghetti strainer, funny enough, to help organize the rope so it doesn't get tangled up during launch. This box here has our observations from outside so that when we baseline the radio sound or the instrument, we can tell if it's reading things properly or not, or if it's a bad one. And then out here we have all of our satellite dishes, observation equipment. There's our rain gauge there, and that's what we use to take data in from here at the station. That dome over there is actually not a radar like most people think. It's actually where the GPS antenna is that tracks the radio sound and radios back all the information back so we can tell where it is and bring back all the data. And then actually to release the radio sound, we put it on that hook there until we're ready, and then it goes up the chute and out the top. So, and that has a retractable roof, so it's not open all the time, but just when we need it. So that's that.
All right, thank you, Molly. So you see there, as we inflate that balloon on top, we obviously have to send that out a tube. And that can get very interesting if it's very windy. And there's a lot of equipment that's up there on the roof of our building, and including one object that you couldn't see that is about a 50-foot tower that is immediately to the southeast of that tube. And so if you have a strong northwesterly wind, on occasion, when that balloon pops out of that tube and you have about 75 feet of string between the base of the balloon and the instrument package, And we do that because, you know, if you go through a cloud and water gets on the balloon, it's going to drip down. We don't want that water to drip onto the device and mess up the humidity calculation. We want that to kind of stay free from the balloon. So there's 75 feet of string there. So the balloon's only going to go up so quick. And if the wind's blowing strong enough out of that north-northwesterly direction, you may or may not clear the tower. Now, I hold the somewhat dubious record of not only hitting that tower once, not twice, but 3 times, and getting a balloon stuck on the top of that tower. And so there's a number of photos that have floated around over the years. That's a joke, floated around, where there's a balloon just floating over the Love Building there on FSU's campus, and people try to figure out what's going on or what happens. And it's actually kind of a big deal when it gets stuck, because one of our technicians that have been to climbing school have to go all the way up there. They cut the string to let the balloon get loose, and then they have to get rid of all the extra string and retrieve the instrument package that's hanging up there. So I'm not necessarily the best at launching out of that tube. So it's a very interesting experience. Launching at ground level can be easier. It just depends on the hazards that you have around. And so that's something that we'll talk a little bit about in our question answer session here coming up. Before we finish our tour, I wanted to talk briefly about decision support and what that is and how we've been able to employ that over the last few years. So decision support is simply providing actionable weather intelligence to enable emergency managers or other decision makers to make timely and well-informed decisions to protect life and property. So that can occur through a variety of ways. It can be as simple as a phone call to our office where you all might ask, you know, is it going to storm tomorrow? That's decision support in its simplistic form. But when we're talking about significant weather events, maybe a large outdoor concert, or we're talking about a big severe weather event, or any of the tropical systems that we've had in the last few years, that might involve requesting one of our meteorologists that have been trained for this to deploy to your county or to work virtually with your county. And you know, these are a couple of these are photos of one where I had been deployed to the Florida State EOC during, I think that's Hurricane Irma in that one. And then Lauren had been deployed to the Leon County EOC during Hurricane Michael. Of course, we've had Justin before he left the office. He deployed to Panama City, Bay County during the Hurricane Michael event as well. And so, you know, any of our forecasters that have been trained for this, all you need to do is ask for that support. And of course, Molly's done a virtual deployment for Hurricane Zeta when it made landfall. And so we're ready to help. All you got to do is reach out and ask us if you have a need, whether that's for an outdoor event or you're talking about an incoming significant weather event. We're certainly there to help. And I did want to include that though not deployable at the present point, one of our youngest honorary staff members, my son Thomas, he often likes to give me feedback on the forecast and what he expects the weather to be. So you see him there in the photo trying to explain to me what I'm doing wrong. So he'll do that often, and I just wanted to include him there in the presentation. So that's all that we have in terms of our virtual tour. But we wanted to leave some time for y'all to ask questions of us. And so we're going to go ahead and pause the recording at this point.